Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely fantastic day. I'm like, 12% sure or something like that. But anyway, so I figure before we get started, let's go ahead and just ramble as we often do. I hope you guys are having a wonderful day, whatever time it happens to be your time. And yeah, there's a lot of stuff to talk about, so I guess let's just get into it. So the other day, how do I put this? Let me just go ahead and open up Zernal and let's draw some things, because I like drawing things, and it's fun, drawing things. So I'm going to open up Zernal, and again, there's a bug, so I'm going to have to draw on it, and then I'm going to have to get rid of it, and then I'm going to have to draw on it again, but that's okay. And 1 second. Good, okay, so now I should be able to use it just fine. Let me pop this over to the next desktop, move that over there. Now, what do I want to talk about? There's a couple things I actually want to talk about. The first of which is, I guess I'm going to say community management or something like this. Let's just say community, something like this. The reason I care about this is because the whole reason I started doing anything online was specifically because I wanted to build a community. Hey JSPP, thanks so much for coming in. And now we have a small community, and I kind of wanted to do things together. You know what I mean? Like something that isn't just me talking into a camera and you guys talking back. I mean, that's nice and all, but there's something more that I want to do. And I'm not really sure what we can do because honestly, my interests and your interests and everyone else's interests, they're all different. But there's one thing that we all do like, and that is programming. Programming. Whoa. Let me try redoing that G. Okay, so here's what I was thinking. Now hear me out. I know I've said this maybe once on Discord, but I didn't really flesh out the idea. I'm a big fan of open source projects. I'm a fan of the idea that you as an individual can go in, contribute, read, and modify any of the source code you see online. I think that's the optimal way to do programming, especially in a large community like this one. A somewhat large community. So what I was thinking about doing are these things that I'm going to call software raid nights. Raid nights. Okay? Now hear me out. This sounds really lame, maybe, to you, but to me it sounds really awesome. The idea is kind of straightforward. You guys know raiding from World of Warcraft or any real MMO or something like that. The idea is you just get a large party together, and this large party goes and attacks a very difficult system. Now, the system could be some sort of dungeon-based thing, or in a lot of games they're just called raids. Usually the party size is anywhere from 10 to hundreds or something like this. And the idea is you just all get together and you attack something very difficult. Here was my idea. We go talk to an open source maintainer, someone who has a project that we all kind of appreciate, but also all agree that could use some help, maybe in terms of programming, maybe in terms of fixing issues, maybe any of these things. It could also be a project that is having trouble onboarding new people. So it could be maybe there's a Julia project or something like this that they really just need more people to contribute to and help with or something like this, So we find the maintainer and we're like, yo, first things first, let's work for a week or two to just get a guideline of all the things that you need to work on, all the issues, all the bugs, all of everything that you need done that you can't do yourself, okay? Or you just want help with. So we get that list of things done. We write it all down and we say, this is what we want to do. After that, we kind of split up all the tasks into a whole bunch of different projects. We'll say that, hey, project A needs to be done by 4 people, project B needs to be done by 2 people, project C needs to be done by 1 person, project D needs to be done here. And we say, this is all the different roles that we need, and then we just kind of queue it up. We wait until all of these roles are established, until we have all of these roles in the community, and they're all willing to give it a shot. And then we just pick a night that we're all available. Probably, it might be a weird time zone for me, it might be a weird time zone for some people, but we pick some time that everyone's available, and we just meet, and we do a software raid, where all we do is we work on that software, we work on that code base until it is up to a sufficiently high quality. And this might require us kind of going through, learning the tools of the trade and stuff beforehand, but I think that's really good, because this means a couple of things, especially for people who are in the software raid. I mean, it means that they can, first of all, put on their CV that they've worked with this software, which I think is really good. I was also thinking about putting a monetary incentive forward. I'm not making that much money off of YouTube, but I don't mind cycling it back into the the community here, because I mean, that's kind of the whole point, right? So I was thinking, hey, I mean, I'm making about $100-ish a month. Why don't I just put this money back in and say, hey, anyone who's doing a particularly good job can get a little bit of money in return. So like we have an MVP, which is voted on by the community, and this MVP gets a little bit of money, and then we have MVP 2 and 3, and they also get a little bit of money. And this is kind of the idea. Now, I realize programming is significantly different than gaming, right? Like, if someone's not pulling their weight in a game, you guys just fail the project, but you can't fail this project. This isn't something that we want you to fail. So, what I was thinking was, if we do this over Discord chat or something like this, that's really helpful. Because if we do this over Discord chat, then let's say someone is struggling. They just put a code snippet up and they say, hey, I don't know how to solve this problem. And then everyone else who might be delayed by this person, rather than getting angry at this person for failing, then goes to this person and they say, hey, look, I know the solution to this problem, I can help you. And that's the idea. Like, instead of, tearing each other down, we build each other up. So I was thinking we could do this in a number of ways. We could have the Discord chat, like the Discord voice chat up and running, and we just do it exclusively via the Discord voice chat. Or I have a corresponding live stream that goes along with it, where we have the voice chat, and I'm kind of like listening to the voice chat in my ears, but I'm also speaking aloud, and I'm kind of directing people. I'm like, hey, look, we need to go here, we need to go here, we need to do this. And so like I kind of just lead people in the right way. So I just basically know the maintainer and know what we're doing. And then if any of the problems come up, basically I just pull it onto my screen, we screen share, and we think about it together bit by bit. Maybe something like this. The details are still being worked out, but I'm really keen to try something like this for a number of reasons. It's beneficial to the open source community, because one of the main problems with the open source community is kind of lack of direction, right? Because the idea is that we have all these different software packages all kind of doing the same thing, but all doing it slightly differently, and it kind of makes the project itself a little bit mediocre, So if we take one of these projects, ideally, after we've tried this a couple times and we know it works out, we take one of these projects, we can actually make it very, very, very good just by focusing a bunch of eyes on it for a very short amount of time. And this, it doesn't fix the fragmentation issue, but if we have a huge community all kind of pushing in one direction, it helps a lot, especially if this community knows programming and we're not just a whole bunch of complete idiots going forward and just trying our best, but we actually have a dedicated plan and know what we're going to do before we go into it. So it takes a lot of prep work, but it's one of those things that I'd be really keen to try. So anyway, if you guys are interested, and you guys want to give it a shot, I know JSPP says it'd be really cool, just feel free to let me know, either here or on Discord, which again, I'll put the link for right here real quick. Discord. If you're interested, just feel free to talk about it there or here. I'm definitely willing to talk about it. And it's one of those many projects that I've been thinking about that I really want to just give a shot. Another thing I really want to give a shot, since we're talking about it, is a charity hackathon. Let's say hackathon, yeah. Now, this is something that would take a little bit more work, and could probably only be done maybe annually, if I'm being honest. But the idea would be something like Zeldathon or like ADGQ or something like this. We just get all of your favorite computer science-y YouTubers, or maybe even mathy YouTubers, slash streamers, slash whatever else, all hopefully in the same area, but maybe working remotely. And we just do a 24 hour, 24/7 live stream for a few days, where we go through and we just say, look, we're going to all work on individual projects. We're going to have a specific time devoted to doing specific, to talking about the progress on certain projects. So for example, let's say we have like 4 different groups, all of them working on different projects. We'll just switch between the different groups, and we'll have one guy kind of like narrating the whole experience. They're like, hey, let's do this and this and this. Now we're talking about this guy about this. Let's get a status update from this guy. And then like they're also potentially doing a whole bunch of mini games with the community, trying to get more engagement and involvement there. Something that really gets people motivated to just kind of sit down and help work on the code bases. And hopefully everything will be open source, so everyone can follow at home relatively straightforwardly. And that's another thing I've been really wanting to do. I have no expectation of a charity hackathon ever reaching the level of other charity streams on Twitch in terms of viewership. But I would definitely like to give it a shot because it's one of the things that I've been really wanting to do recently. There's a few other things that I wanted to mention, but since we're talking about it and we're still waiting for people to come in, I figure I'll mention one last thing, which is that I've been kind of thinking a lot about like the future of this channel and stuff like that. And I think, as I mentioned before, the moment I leave OIST, it's going to be very difficult for me to keep this stream up because my next job will probably be conflicting in terms of working hours and stuff like that. So I have to redo the time in which I'm streaming and all this other stuff. And I don't know, I don't think that's exactly fair for you guys because I've been streaming at the same time for ages. And even though we don't really have that large of a community, it's one of those things. Hey Night Owl, what is up? We're just talking about different community projects we could do together. If you're interested, I can rehash one of them, but that's okay. The first split up comes from the different language experiences. I wouldn't try to code on C++ things. Yeah, that's another problem. Like, we'd have to say that this raid is specifically for Julia developers or something like that, or C++ developers or something, you know? Which would mean that some of the raids, like, I just wouldn't be able to help with because I don't have sufficient experience in that language. On the other hand, this is also kind of the build-up, right? So, like, the way I see it is if we're going to do a software raid, we're going to have to take that month before and really just ramp the community up, you know, say, hey, this is how the project works, this is why it works this way, provide a whole bunch of, you know, maybe not even tutorial videos, but just like a whole bunch of documentation and say, hey, here's the basics of C++, here's the basics of Julia, here's the basics of this language, here's how you do this, here's what you do this for. And again, this is helpful for the maintainer too, because the way this works, there were a lot of maintainers have trouble with documentation, they have trouble with onboarding new people. So if we have the software raid going on, we can just say, hey, look, all we're asking you to do, or all we're asking, is that we make the documentation of this project a little bit better. And I think that's ultimately a good thing. Yeah, so I'll see Sharp just do one thing. Yeah, I think a subgroup with different languages would be a good idea too. Yeah, that's actually a very good idea, I think. So, if you know the basics, you don't write good code though. Yeah, I agree with that. Like, we need like one experienced Julia dev or one experienced C# dev kind of sitting there and helping you out with it, or one experienced C++ developer, which we have a lot of. So I think C++ would be a language that we might want to start with and then kind of go from there. Obviously, this can only happen if the maintainers are up for it. So I'd have to email a bunch of maintainers and be like, yo, what do you think about this project? Would you be interested in helping us out? This type of thing. And I think that's something really good to build the community on, these types of software raid nights and maybe like a hackathon and all this kind of stuff. There's a whole bunch of things that I wanted to do. But as I was saying just a second ago, the project can work for sure. Yeah, the thing I'm most worried about this project is if we gave it a shot, we want to start small, like just do a very small one, like just to test to see if we can get all of the software and everything running in sync and see if we can actually kind of hype it up and all this kind of stuff. Because quite frankly, we're going to have to do something to make it seem really cool, and I don't know what that's going to be. I would love to have like some central announcer guy, which I suppose would be me in this case, at least for the first one. And we could switch between announcers that basically says, yo, you know, we need more people over here. We need a couple people over here. You know, what are we going to say? Subgroup A just finished their project here. That kind of stuff. Hey, friends. Also, Night Owl, I don't know if I specifically said your name, but thanks so much for coming in. And so that's kind of the way I envision this happening. Having one central guy who's just like, hey, we need help here. We need to do this. And maybe it's all via Discord chat or something like that. Not sure, but that's definitely something to try out. So yeah, there's still stuff to work out there, but that's where we're at. Now, as far as the stream stuff is concerned, I did mention that in a year when I apply for new jobs, it's going to be hard for me to be streaming. I mentioned that, then I got sidetracked with something else. The reason I brought that up is because I'm thinking in a year when I'm applying for jobs, I might also open up a Patreon at that point. Right now, it doesn't look like I have too many subscribers on YouTube or followers on Twitch or anything like that to really try this full time. On the other hand, I was thinking about the idea here. I was thinking about a whole bunch of other people. I was kind of watching their statistics, and in a year, I mean, a lot can change in a year. So if we have enough, you know, followers and we have enough of a dedicated group of people, maybe I could try doing this full time, which would mean more community projects like this. So again, if you're just popping in, the idea behind both of these guys are the following. The software raid night is basically, we pick an open source software project. Doesn't matter what it is, just some open source project. We talk about, we talk to the maintainer about this project, and we say, hey, what do we need to do to make this project great? And so they'll have a whole bunch of issues, a whole bunch of bug reports, a whole bunch of like wish list items, all this kind of stuff. And then we say, okay, here's the list of things. Then I and some other people work with the maintainer to upscale the documentation, make sure that everyone understands exactly what's happening, parse all the problems into specific subgroups, saying that we need 5 people here, 2 people here, 3 people here, and then we meet all at one time to basically do a raid on the software where we all program together and we all work on making sure that this software has all of the bugs fixed, all of the issues fixed, and we kind of focus on making it good, you know? And then we kind of focus all the community in one area for a short amount of time and just pummel through all the bugs at one point in time. And I think if we have enough people, we can do a lot of good here, as long as we're focused and we have the right community and all this kind of stuff. We need a couple directors, you know, to make sure the community is going the right way and stuff like that, but it's something I'm really keen to do. The charity hackathon is basically what it sounds like. We get a whole bunch of popular streamers, YouTubers, that kind of thing, put them in the same, I guess, area, and have them all kind of work on their own projects with a central announcer going through and saying, hey, here's the idea. Here's what this group's doing, here's what this group's doing, so on and so forth. GSPP, WTF, that huge Twitch library for C# doesn't have an event. On stream started. Yeah, Twitch, man. I don't know. Okay, so those are these 2 community projects. I spent too long rambling about them. If you're interested in either of them, feel free to let me know, either here or on Discord. I'm definitely keen to try one out. I just don't know when or how or where or any of this kind of stuff. So I need to kind of think about it. And I need to come up with some open source projects too that people would be interested in working on. Okay. So that was like a 15-minute ad. Sorry about that. That just took a while. It always takes a while on stream. Okay, so let's talk about what we're going to do today. So new page before. Last night, I went through and wrote down a good bit of implementation details for Huffman Encoding, as we said we would. And I basically noted that there were a few things that I need to learn, but I figured I could learn them on stream. Basic things like how to use particular data structures in Julia, and all this kind of stuff. Sorry for the yawn. So I was thinking, first things first, we learn how to do that. But for now, let me go ahead and describe what we're intending to do. So what we want by the end of the day is a working version of Huffman Encoding. And again, this might be by the end of the day tomorrow. So Huffman Encoding. Now, I discussed this in a lot of detail yesterday. Suffice it to say that we're going to have some sort of string that we're reading in that we want to encode into a certain number of bits, and we want to minimize the number of bits that our string turns into. So, quickly, anyone in chat, give me some sort of string, some sort of person, place, or thing, a noun, just something, you know, something that I can encode. And then after that, I'll encode it here and I'll show you how Huffman Encoding works. Keep it short so it's a little bit easier for me, but not too short. So I'll wait for you guys to say something there. While I'm waiting, I just want to say that Huffman Encoding is actually one of those algorithms that got me into algorithms to begin with. Like, I'm super keen to come back to Huffman Encoding. It's been a while. The brown fox sentence. What is the brown fox sentence? I know which one you're talking about. It's like something jumps over a brown fox. Oh, I know how to find it. Ooh, this is dumb. I'm sorry. Vim is better than Emacs. 1 second. I'm gonna pop over here. I'm gonna go to options. I'm gonna select font. It is the quick brown fox jumps over the lazy dog. That's kind of long. Vim is better than Emacs. Okay, so I'm gonna do this one manually. How about I just go with the brown fox? That one sounds good. So I'm just gonna say the brown fox. That's what we're doing. Okay, the brown fox. Okay, so what I'm going to do first is I'm going to go through and count all of the different characters. So we're going to do T, H, E, space. Then we're going to say brown, B, R. Oh wow, there are like no similar characters here. O, W, n, okay, f of times 2 x. There are no similar characters there. Huh. Except for the space twice. And the O twice. Let me try a different phrase so I can actually describe what Huffman encoding is a little bit better. Maybe I shouldn't have done a random phrase. I'm sorry about that, guys. Let me try this one more time. So I'm just going to pick, I guess, a random phrase. Let me think. Something that works with a large number of similar characters. Doesn't Huffman use a bit stream? I mean, it has a character stream being read in, and then from the character stream, you go to a bit string. So, okay, let me just, fine. Never mind, I'm just going to go with this. We're going to go A, B, B, C, 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 D, D, D. That's what we're going to D, okay? So this means we have 4 Ds, 3 Cs, 2 Bs, and 1 A. We list these characters in basically the order of probability that you would find them. So this would mean that there are 4 out of 10 Ds. So this means we have D, and its overall rating is 0.4. We have C, and its overall rating is 0.3. We have B, and its overall rating is 0.2. And we have A, and it's 0.1. Right, so the idea is that we take all the characters, we basically put them in a hat, we shake them up, and the probability that you're going to find a single character when you pull out a random letter is this probability here, okay? And we want it normalized to 1. It doesn't have to be, but it's kind of common notation. That's how it is. What we do is we basically combine the lowest 2 values here together. So we'll say 0.2 and 0.1 combine to be 0.3. 0.3 plus 0.3 combined to be 0.6. 0.4 plus 0.6 combined to be 1.0. Okay, so now we talk about the bit strings. We have 4 different characters here, D, C, B, and A, and what we need to do is figure out what these characters are in their bit representations. So D is just going to be 0. C is going to be 1, 0. B is going to be 1, 1, 0. And A is going to be 1, 1, 1. What I did is I basically went through all of these different branches, and every time I took a right, I put down a 0. Every time I took a left, I put down a 1. And so now we just go left and right over and over and over again until eventually we're at the character that we want. And when we get there, we then have a bit representation for that character, which means that this string corresponds to 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, and then 0, 0, 0. So you might think to yourself, well, okay, that's fine, but how do I know that this is the optimal string? Like, how do I know when I just encoded this data that the encoded bit string is actually better than maybe a random library or a random other set of bit strings? And the answer to that is, well, what we can do is we can actually multiply the probability of each of these guys by the overall bit string length here, if that makes sense. Yeah, we're talking about compression. How do we know that we have the minimum number of bits possible after we have read in our different bit strings here? I'm kind of going through this faster than I did yesterday because yesterday I kind of went through this in a long, overdone way. So today I'm kind of going through it a little bit lighter. So then the question is, how do we know that this is optimal? So how do we know? I guess I'm gonna ask optimality. I think that's a word. So that's our question. How is this optimal? Okay, so the answer to that is new page before. We have a measure that's known as L, which is going to be equal to the sum of basically all the different probabilities times the length of the bit string in the end. So for example, D has a probability of 0.4 and it has 1, and its length is 1. C has a probability of 0.3 and its length is 2. B has a probability of 0.2 and its length is 3, and A has a probability of 0.1 and its length is 3 again, right? So this is because we do go back a page here. Length of 1, length of 2, length of 3, length of 3. And Here we are. If we multiply 0.4 by 1, we get 0.4. 0.3 times 2, we get 0.6. 0.2 times 3 is 0.6. And 0.1 times 3 is 0.3. And adding this together, we get 1.9. Okay? So for our particular set of code words, we have 1.9 for this value of L. Now, let's say we tried a different set of code words. Instead of what we had before, we try another set where we have 0, 0, 0, 1, 1, 0, 1, 1. Okay? In this case, my bad, wrong way. In this case, instead of having 1, 2, 3, 3, we have the following for the second set. So again, we have the same probability and everything, but now we have 2, 2, 2, 2, which means if we add all of these probabilities times the lengths together, we get 0.8, 0.6, 0.6, 0.4, sorry about that, and 0.2. Adding this together, we get 2. 2.0. Okay, so if we compare 1.9 to 2.0, we know that 1.9 is lower than 2.0. And then what we do is we say, okay, that means that this alphabet here is slightly more compressed than this alphabet here. Okay, so that's our measure of that. Dictionaries are binary trees with indexes of nodes pointing to redundant characters or bits. Is that true? Dictionaries are binary trees with indexes of nodes pointing to redundant... Oh, I see what you mean. Yeah, sure. Okay. For this particular case, I think I understand. Okay. So now what was I going to say there? So now we have this measure. We know that Huffman Encoding provides a library or a set of code words that is somehow more optimal than the other set of code words that we could be using. So that's really cool. Now the question is, how do we express this in code? Before I continue, I do want to show you a very quick visualization of this, just because I find the visualization somewhat interesting. So we're going to cd into projects, Simuleos, Huffman, ls, and let's go into Mirage and then Huffman.gif. Okay, so here's a basic visualization of that happening. I took the phrase, what was it? It was Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came tumbling after. And I encoded this in this phrase. Space is the most common. A-L, let's see, E, N, I-T are all second most common. These are third most common, fourth most common, fifth most common. And so basically we just put them into a tree, we line them up, we go through left and right, until eventually we have the final bit strings, which are then falling from the bottom there. So that would be the basics of Huffman encoding in a more animated format. This is what I'm going to be putting on the video when we put it up. WinZip nominal is 14 bits entry. I guess you mean the minimum file size in which you can zip with WinZip is 14 bits. Which I guess is fine, fair enough, or is it the minimum size of the zipped object 14 bits? Not quite sure there, but that's okay. So that's kind of the overall idea. New page 4. Okay, so now obviously in order to get this to work, we need a couple of things. Now what we're going to do today is a very basic implementation. There are some other implementations that were mentioned yesterday, but I haven't yet gone through and worked out the details on that one. My goal is to do that either today or tomorrow. So I think this will take maybe a day and a half to implement. And then the next one should also be implemented in roughly a day or and a half. So dictionary entry for binary tree nodes. Wouldn't we do level by level from the start? So first assign to the most common, then the second, and so on. When we do level by level first. Oh yeah, so first we have to order it. I don't have a project command, Gamili, but basically the idea is that we're working on a book filled with algorithms along with a YouTube channel. Basically, we're just going through algorithm by algorithm, learning how it works and putting it into a centralized format. So we have this stream where we talk about algorithms. We have a YouTube channel, which then talks about the algorithms again, but in a shorter, more concise format. Then we have the algorithm archive where we have like kind of a list of all those algorithms put into a written format. And of course you can contribute your own code to the algorithm archive and stuff like that. So in case we do have new people, let me just go ahead and work through each of these individually. So let's see, algorithm archive. This is kind of the main project that we're working on. It's, I think, really cool. So we go to read. And like if we choose any of these at random, let's go to I don't know, tree traversal or something like that, you can kind of flip between the different languages. So if you wanted to submit code in your own language, feel free to do so. And that's kind of the idea. It's just some big project where we all kind of learn about algorithms together. And that's the whole thing. So this, and obviously YouTube, and go from there. Year one gone red from left to right, not top to bottom. As great as all compression formula are, they still rely on redundant patterns, right? This kind of depends. So now I'll be honest in that my data compression knowledge is not as, I guess, in depth as I would like it to be, but for the most part, Huffman encoding requires some sort of redundancy in order to compress data, or some sort of pattern at the very least is necessary for data compression that I'm aware of. Now, there are a whole bunch of new techniques that I'm not familiar with so much, like, for example, there's ways to use genetic algorithms in order to minimize data. There are machine learning patterns used to minimize data, and these will probably minimize data in weird ways that I'm not quite confident in saying that the only way it works is... I think you just saw the visualization wrong, JSBP. I'm not sure what you're saying. But yeah, the color scheme is based on level. So it's based on the weight. So red means it was used a lot. Green means it was used very infrequently. And then we have basically all these different levels that are based on the color. So they are already kind of set in level by level, but the implementation details here, the way we implemented it was slightly different. And I was going to go into that in just a second. As great as so there's a whole bunch of different compression or data compression methods here. And again, we'll go through those in time, but it will take some time before we go through that. Honestly, it's gonna, the algorithm archives is a super ambitious project. It goes blue from left to right. Oh, yeah, sure. This is kind of, it doesn't really matter how you read it. We used a depth first search here that just went left to right instead of right to left. But it ultimately doesn't really matter which way we go, if that makes sense, right? So, we could have chosen to take the right node first instead of the left node first. We just went left to right because that's, for some reason, what I wanted to do at the time. So, the depth first search is what we used in the end to basically append to a bit string and determine what the bit string was as we went down. So, I think there could be a more efficient way to do it, which we'll probably talk about tomorrow. I'm not sure how far we'll get today, but it might take a little bit longer than I was anticipating before. Okay, so let's see what we can do. So let's talk about the implementation details of this particular system. I'm going to pop over here. So what we know is that we need some sort of representation of each individual node. And in each individual node, we're going to need a couple of different guys. The first thing is we're obviously going to need a left, right, and we're obviously going to need a parent. Okay, let me lowercase this r because the others are lowercase here. And these are all different nodes. So I guess, I'm not going to notate that. We also need some sort of weight. And then we need the character itself. So this all should be held within an individual node. Now we're going to need a couple of different guys here. In the end, the easiest way, I think, to represent a, or to do Huffman encoding is via a priority queue. And this is what I was saying, I need to look at some Julia data structures really quick, because I know that there is a priority queue in Julia. I have used it before, but it's been a while and I don't really remember the exact notation to using it, so we need to hop in and figure that one out. But using the priority queue, basically, if you're not aware, the priority queue is a queue that when you put new data into it or you put new elements into it, the elements are automatically sorted. So the idea then, they use branch and recursion, not node, branch, and recursion. Yeah, I don't know exactly what you mean by that. They use branch and recursion, not node, branch, and recursion. Are you saying they use a breadth first search instead of a depth first search? Yeah, I'm not quite sure. Sorry about that. Okay, so the easiest way to do this, I think, is with priority queue. Basically, we put all the nodes together in the priority queue and sift them based on their weight. So similar to what we had before, here are all the nodes, and this is the weight for each of the individual nodes. I'm sorry about this song. The blue thingy comment. Yeah, again, we just did a basic depth first search of a binary tree. We didn't do anything complicated there. Okay. So this priority queue will then basically put everything in an order here, and then we'll throw everything back into the queue and basically keep popping elements accordingly. So this allows us to very quickly go through all of the different nodes and add them together and kind of create this final element number there. Okay, so we need a priority queue. And so basically we need a function that will go through and create this priority queue for us to iterate through, or I guess move through. So we're going to need a function to create the queue, or at the very least create the tree. So we need some sort of function. We're just going to say create tree, which is going to do the following. One, it'll iterate through the string. So we're going to say iterate through string that we want to encode. Two, we want it to create a vector and sort the vector. So create and sort vector. Hey Tribute, what's up? I just want to say your videos on YouTube are awesome. Thanks, man. Really appreciate it. In case you guys don't know, I have a YouTube channel, so feel free to check that out. So we need to create and sort the vector. We're going to say a vector with the different weights. With weights. Like walking a nested directory structure. Yeah, that's basically it. Also, guys, if you want to talk about anything in chat, feel free to do so. I obviously don't have any restrictions to what you guys can say. As long as you don't talk about like overly disgusting or like things that are clearly like, I don't know, like in a nature that would get anyone in trouble, just stay away from that. But feel free to talk about anything else. So I hope you guys are having a fantastic day. Let me know if anything cool happened or if you guys are in trouble or something like that. You know, just feel free to talk about whatever. So now we want to create all the different nodes. And put them into the priority queue, which I'm just going to notate as PQ. 4, after that, what we need to do is we need to continually add smallest nodes together. And then replace with parent in PQ. Okay, now 5. What do we need to do after that? Oh, actually, that'll be it. Because if we do this and we keep adding the parents together, then all of a sudden we have our binary tree. And in the case that you want to see some sort of visual representation, here's basically the idea. So we have, let's say, node 1, node 2. This guy becomes the left node, this guy becomes the right node, and then what we do is we create node 1 plus 2, which becomes the parent node, and this one is put back into the priority queue here, which will then be basically tested with all the other queues that are already there. So like, for example, if we have a whole bunch of nodes put together, then we put this back in the priority queue, it's reorganized so that we can figure out which nodes are then added again after that. The cocaine deal, I don't even do Coca-Cola, let alone cocaine. So we'll need a couple other functions, which I'm going to go in new page before. One thing to note is that this Huffman scheme, the scheme that I said before, is known as 2-pass Huffman. Huffman encoding. And the reason for that is somewhat obvious in hindsight. We have to go through the string twice in order to create the Huffman tree. There are single-pass Huffman encoders and stuff like this, but for the most part, we have to go through the string once, figure out the probability of finding each of the individual characters, then create the bit length, and then go through again to encode. So we cannot encode while we're reading through the string. Single-pass Huffman encoders or dynamic Huffman encoders can do things slightly differently. So what we need then is we need a couple of other functions, one to encode, which this guy basically goes through. Well, I guess let's go at the start. We need one to create the map, right, or the dictionary. This one basically goes through and does some sort of depth first search. Ooh. To find the bit strings. Right, then it also does, let me put a 1 here, and then 2, it places all of these So it places the bit string, so it says bit strings plus character map. So this means A will be 0, 1, B will be 0, 1, 1, that kind of things. So then we also need encode. This one's super easy. It just goes through the string and uses the map. So I'm ignoring a whole bunch of stuff here, by the way. It goes through the string, so string plus map equals code. And then we have decode, which is the opposite. So notationally, this is string clearly minus map equals code word. Yep, this is common notation. Totally great at this. Ever since my early days of coding, I always interested in compression methods. Ever come across uncompressible files due to entropy? Yeah, so this is actually a really cool topic that I want to talk about in the future. Since you use Linux exclusively, what do you think of Windows or Mac? Any big reason why you're Linux only? I'll get to that in just a second. Let me see what everyone else says. There are a few libraries for compression data. All OSs can be used for code development. I wouldn't use Windows because it's basically spyware though, so is Mac. Okay, so let me talk about that real quick since I do get this question a lot, and you know, I'm sure a lot of people have already heard it, but hey, I never actually used Windows, not as an operating system on any of my computers. What ended up happening was when I got my first computer and I was like 14 or something like that, due to some rather weird circumstances, I couldn't figure out how to use the computer. It was the first machine I'd ever gotten that had Windows Vista on it. My own computer at home had Windows Millennium Edition or something like that at that time. So I wasn't really used to using a computer so frequently. I went on, I downloaded some antivirus software. That antivirus software conflicted with the antivirus software that came naturally on the computer, so I couldn't connect to the internet. It took me like 5 hours just to get online because I couldn't figure out what the problem was. A whole bunch of issues, you know, just kept running into issues. The computer was slow and buggy, wasn't working the way I wanted it to, so I just downloaded and used Linux. Took me all week and weekend because I used Arch Linux for the first time. And obviously I was a complete noob at computers. I couldn't even get connected to the internet for Pete's sake on Windows. So like I wasn't particularly good at anything. But when I installed Arch Linux, it was the first computer that I'd ever seen that I really felt like I understood from a bottom-up level. And that's the thing that I cared about most. I didn't really care about, obviously I didn't really care so much about gaming. I didn't care so much about anything else. The fact that I kind of understood what was happening on my computer was very important to me. And so since then, I've basically used Linux exclusively. And you guys are right. There's a whole bunch of things wrong with Linux. You know, the fact that everything is open source isn't necessarily a good thing. It's great in terms of like security and usability, but on the other hand, it's not so great because, you know, a lot of the software is not developed by like true paid developers. It's developed by a community, and the community could be fragmented. It could have a whole bunch of other issues with it. But as far as my thoughts are on Windows or Mac, I get frustrated when using Windows, particularly because when I'm using Windows, I want a particular system. And when I'm using my computer, if I don't have the system that I'm used to using, then I get really frustrated. And in particular, I really need a Unix terminal to work. I can't imagine working without a terminal. Like, it just boggles my mind how people do it. So like, a computer without a terminal is kind of a useless technology to me, just because I can't use a computer without it. Like I launch Firefox by typing Firefox into my terminal. Like that's how I do everything. Like everything has a terminal. Like look down here. You might not be able to see it because my face is over it, but on this desktop alone, and I have 4 desktops up, I have 1, 2, 3, 4, 5, 6, 7 terminals up, all of which are running something in the background. And it's just, to me, it boggles my mind that people somehow use a computer without a terminal. Now, Macs I can kind of deal with because you have the Unix terminal available, and now that Windows has the Ubuntu subsystem, I can kind of use it to some remedial degree, but ultimately, for the most part, I do everything SSH'd onto a supercomputer anyway, so it's very just unnatural for me to use UIs. Was your first exposure to Linux non-GUI? Yeah, my first exposure to Linux was via Arch Linux, and it had a small GUI prompt to kind of get you started, but it was basically non-GUI. Although my Mac and Linux.file repos are interchangeable for the most part. Yeah, that's probably also fair enough. I mean, there's a lot of similarity between Mac and Linux, so I'm usually kind of okay using a Mac. but man, I just can't figure out Windows to save my life. It's just like, I know like everyone else can figure out Windows, like my grandmother can figure out Windows, but every single time I try to use Windows, I just fail miserably. It's like the same time, like, I have this tablet. I have this freaking tablet, and like 3-year-olds can figure out how to use a tablet, but I cannot fundamentally figure out how to use it. You know, like I use it for like 3 things. The first thing is reading papers. So like I read scientific papers and I notate them. That's the main thing, which is why I have a tab or a pen that goes with the tablet, because otherwise it's kind of a useless device. Then there's like touchscreen things. I can't figure out for the life of me how to type, and so I literally just write things out with my stylus and hope that it recognizes the appropriate words and stuff like that. But ultimately, like I don't know how to use basic technology. I'm really bad at it. And so when a lot of people like say, oh, you know computers, you can definitely help me with this. I'm like, nope, I have no idea what you're talking about. The moment they start talking about Windows specific things, I'm like, can't help. I have no idea what that is, and I'm not willing to put the time and effort into learning something that I know I'm not going to use. So, okay, what do we have here? Typing on tablets is BS anyway. Linux prompt, what security level? I'm not actually sure. Although my Mac and Linux file repos are interchangeable, you need an external keyboard for that. Yeah, I was thinking about actually bringing my keyboard around. I actually have a specific adapter so that if I wanted to, I could connect my mechanical keyboard I have here to my tablet, because I thought about that before buying the tablet. And again, the tablet is mainly just used to read papers anyway. But anyway, sorry for the long ramble about that. Still waiting for the true Linux mobile phone. I thought there were a few out there, weren't there? Like, I guess the Ubuntu phone doesn't count. What about like, there was this Sail OS or something like this? There were a couple out there. The only time I had ever considered actually buying a phone was when I found like there was a Linux phone out there, and I was kind of interested in that. Outside of that, like the phone that I currently have, actually I don't have a phone right now. I haven't had a phone in like 4 years or something like that, which is kind of annoying because like a lot of times people require like 2-factor authentication, and for some reason they just assume that you have a phone, and I'm like, well, that's kind of stupid. You know, why would you assume I have a phone? So anyway, so that means that a lot of times I can't do something because they require like me to have a phone, and I'm like, yep, don't have a phone, so can't do that. And a lot of times it's like banking and stuff like that. So it's like, why on earth would you require this? But also like Twitch requires it, so I can't become like an affiliate. It's one of those things. A Windows security level is divided into sessions, 0 being OS and 1 the user. Something happens in session 1, then OS is still protected. Oh yeah, okay, so I'm not sure exactly how that works on Windows, but you do have multiple like levels of security in Linux, basically. Like you have the root user, which you can log into on the terminal, but you also have individual users, which are basically different levels of security based on which groups you have allowed them to have access to. So like, for example, you as a base user only have access to your individual home directory, and you cannot access the rest of the computer unless you use some specific command in order to access the rest of the computer, or have used a command to become the super user in order to do that. So this is what the sudo command does. It turns you into a super user, and then it does whatever you're supposed to do. So super user do. That's the whole point. So as far as the security is concerned, I mean, again, I don't know anything about Windows or how it works, but yeah, so it's naturally the user level. The terminal in Linux is naturally the user level unless you do something specific to get extra security access, which again, on like supercomputers and stuff like that, which 99, almost 100% of them use Linux. In these cases, you don't have access to the super user rights, so you cannot use that those certain commands that require super user rights on supercomputers. So that's kind of the idea there. I don't know, James, maybe they assume you live in the 21st century. Yeah, okay, fine, fair enough. Me not having a phone, I realize, is like caveman times. I apologize for that, but it's just weird. Like, why would you need a phone to live? Like, I don't understand the utility in having a cell phone. I understand having the utility of having a data plan. Don't get me wrong, like, I understand that. if I'm walking around and like I need to figure out where I am, it's nice to have Google Maps available to me. But Google Maps is basically the only thing I can think of that I really would want a data plan for. So why not just use a GPS or something like that, which is less expensive and works better in a lot of cases. Not all cases. I think Google Maps is actually better than a lot of GPSs. It depends on the GPS you get. I'm not familiar with Linux OS, so I was curious. Windows, even admin login, cannot access session 0. Yeah, I'm not really sure. No, Ubuntu is beginner-friendly version of Linux World. Call ambulance, chatting with family, online things. Yeah, fine, fair enough. Calling an ambulance is probably the most important thing there. Let's see. Distro, two-factor, Simulatios. I actually need a phone for development at work. Yeah, I could imagine, like, if you're working on a lot of phone apps or something like that, that's true. Also, clearly, I'm in the minority here, because, like, if I look at my YouTube statistics, I think, like, 60% of people watch it from, like, a tablet or phone device. So, I'm clearly in the minority here. I'm not trying to argue from the majority perspective. I'm just saying from my perspective, there are very few reasons why I would necessarily want a phone walking around with me. You know, I'd rather just... most of the time when I need Wi-Fi, it's like when I'm programming or something like that. So I just bring my computer around and have a one of those Wi-Fi boxes. Years ago, I did buy Red Hat, but never did anything with it. Why did you buy Red Hat? I guess for a server or something like that. Usually people just use Fedora instead of buying Red Hat. Well, you can use simulators, no actual phone needed, really. Yeah, that's also true. It's just the main thing is I just need a phone number. I don't really need a phone. So I guess if I could find a way to assign a phone number to myself, I think there's like a Google phone number or something I could use. In that case, I would just use that because I don't really need a phone. I just need a phone number because I need to authenticate things, you know, especially when you simulate touch events. Yeah, that's true. I completely agree with that. I tried using like Android Studio or something a while ago, and it worked pretty well, but it was kind of different when I tried it on my tablet after a while. Yeah, LIC server, but project changed to Linux. Changed to Linux went out the window. Yeah, it's I don't know. I mean, I know that Windows is the most used operating system on the desktop. Don't get me wrong, I totally get that. And again, I know that I'm going against the status quo, so not trying to argue from the majority perspective here. I'm just saying that it's weird to me how dominant Windows is because it's like, it's just so backwards to me. Like everything I try to do on Windows, it just doesn't work. And like it's always buggy and it's just always problems. However, I will also say that I have Ubuntu on a system at work, and I will say that Ubuntu system has given me more trouble than any other system I've ever had, besides certain Windows systems. But in comparison to all the other Linux systems I've had, this one system is a pain in the butt. So I kind of understand where people are coming from when they say that Linux gives them trouble, because it does. It has been giving me trouble recently. And if I'm using a distribution other than Arch, I have a lot of trouble with it. So I can totally understand why other people are having trouble with Ubuntu and things like that. So that's kind of how it goes back and forth. I kind of hate how Google forces a lot of Android devs to use Android Studio and do a lot of things like install the packages they need. Yeah, I didn't realize it had gotten so bad. I thought that people could still use Eclipse and stuff for it. But I guess maybe it has. I did this a few years ago. So Android Studio was actually relatively new when I did this. Might be for what I worked with till now, it was pretty good. Didn't really much with it. Let me think. To be honest, when it comes to tech-related people, CCC and so on, Windows is really not often seen. I don't know what CCC is, actually. I prefer doing everything in the command line. Yeah, me too, but obviously I do. I mean, like, if you look at the way I code, it's all terminals. Okay, so let's go ahead and get started writing this Huffman code. Let me get a quick sip of water, and then we'll go ahead and work on that. And again, if you guys have any comments, questions, concerns, feel free to let me know in the chat box over here, and I'll do my best to respond to it as soon as I see it. Okay. So let's see, I'm going to go ahead and cd into projects, Simulatios and Huffman over here. So I'm in the same directory, and I think I went ahead and opened up a Huffman.jl file as of last time. Yep, sure did. So there's one thing I want to do before getting started here, and that is take a look at the priority queue in Julia. So I'm going to go ahead and open up the Julia command prompt over here, and I'm going to do using data structures .jl, which I'm pretty sure that's where it is. Dang it, one second. Oh, what is it? Is it... One second, maybe it's this? You can tell my Julia syntax is rusty. There we go, that's what I wanted. What is the node tree print? Would say devs use it and consumers, but hackers, security people, some devs and so on don't really use Windows. Linux with Windows is like car versus Jeep, different characteristics and abilities. Yeah, I'll agree with that. Chaos Computer Club. Oh, okay, I see. I would say that mostly about security and hacking. No one uses Windows and is serious about it. That said, again, if you're an app developer, Windows is what you need to develop for, and that's fair enough. What does the node tree print? I don't know. I still don't know if I fully understand what you mean by that question. Sorry, I'm just kind of drawing a blank there. Okay, so what I want to do is go over here and take a look at priority queue, Julia. Collections and data structures. I know that there is a priority queue, or at least I'm pretty sure there was. Stack queue, priority queue. Yep, so it is here. There's some documentation there. Okay, now here's the thing. I remember I looked into this a few months ago, and the documentation here was, I don't think it was that bad, but it was kind of lacking. It looks like it's a little bit better than it was back then. So I'm going to basically try this and see how it works. JSPP, and even so, for most devs, it's actually easier to develop in Linux and Windows. Very opinionated there. I think a lot of people, if they're not used to Linux, will have trouble with it. And if they are used to Windows, they'll be fine with it, you know? Again, personally, I just use Linux because it's what I'm used to using. The day I came in there, they asked me if I had Linux installed and or if I wanted to do that as a first project. Oh, wow. Yeah. So I know I've been rambling a lot today. I do a lot of rambling. What is Julian other than data format? I don't... Julian. One second. Is that a data format? Yeah, I don't know. So Julia is a programming language specifically meant for... so it's called Julia. It is a programming language. It is... basically, it writes like Python in a way. But its speed is basically as fast as C. So it's meant particularly for number crunching. It's good for... it's basically replacing MATLAB. And it's a little bit easier to use MATLAB. It's a little bit more consistent with other languages. And it's quite, I would say, straightforward to use. However, there's also a bunch of tricks to it that can make it more efficient. So that's kind of where you get there. I know I've been rambling a lot today, but there was a time, a long time ago, when a lot of my friends were very... I mean, they didn't really do much. Like, they were basically spending a lot of their time playing video games and not really doing anything. And I felt really bad about this. So I tried to get them into programming and stuff like that. And it worked for, I think, one or two of them. They got into computer science because, basically they were spending all night playing video games or something like this, and every once in a while I was like, hey, how about you come over and we learn Linux together? Or hey, how about we come over and we do this together? And so basically we did something computer sciencey together, and the rest of the time we played video games. I didn't try to really stress it too much. But for me personally, these nights when they came over and we did Linux stuff, or they came over and we did programming stuff, those are some of the most fun nights I'd had in a very long time. When we just had a group of people together and we were just learning things together, it was a lot of fun, and I really enjoyed it. Way more than I enjoyed any type of gaming or anything like that. I mean, don't get me wrong, the gaming was fun, but I mean, ultimately we were just playing League of Legends or something at the time, and it wasn't, I mean, it's fine, but they enjoyed it more than I enjoyed it. And I'm sure I enjoyed the Linux stuff way more than they enjoyed the Linux stuff, but it was super fun for me, just to have a whole bunch of people together, just kind of working on something, kind of educational and fun. And so I think the reason I bring this up is just because I think there is a lot of merit to just installing Linux for the first time, trying it out, figuring out how the new operating system works. Even if you don't use it, it's kind of nice. Yeah, I think Visual Studio. I haven't bothered with much CMD prompt. I mostly use CMD-ER, so I get a lot of NIX utility ports. I don't know anything about Windows terminals, but yep, getting the NIX thing is good. Yeah, again, so the Ubuntu subsystem is kind of the most important thing I think that Windows has added recently. Okay, so it looks like the priority queue has a few different uses. Construct a new priority queue with keys of type K and priority and properties of type V, okay? So priority queue, KV, ORD. So what I need to do is create a priority queue of different structs. And these structs will ultimately be nodes, but for now I just need to kind of figure out how to create the priority queue with a particular priority for some sort of ordering, if that makes sense. Like I want to order it based on a particular value inside of the struct. In our case, the struct will be a node, and the value we want to order by is the weight of each individual node. So first, let's get something very basic down. Just some sort of priority queue with just A, B, C, something like this, like we have. And it's basically used like a dictionary, so this should be relatively straightforward. So let's try it out. So we're going to say PQ is going to be equal to priority queue. Priority queue here. Okay, so now we have the priority queue generated, and we're just going to add a couple values in. So we're going to say PQ of A is going to be equal to 10. Let's say B is equal to, let's say 12. And we're going to say C is going to be equal to 9. Okay, so now what we should have, assuming the priority queue is appropriately ordered, I want to just go ahead and say PQ, and it should say, yeah, so it is appropriately ordered. So if we put in another one, which is D, which is 5, it should appear before C. Oh, that wasn't what I wanted. I did this backwards. D, which is 5, and if we put another one, which is E. Oh no, it's not appropriately ordered. Oh shoot, which is 13. And now we do PQ. Yeah, okay. Wait, let me try it again. The heck? What is this ordering? CEBA 9, 13, 12, 10, 5. I'm not sure what that ordering is at all. Well, that's weird. Okay, so I have to think about this a little bit more. So the priority queue is the easiest way to get Huffman encoding implemented so that we don't have to keep resorting a vector every time step. But ultimately, the resorting of the vector would basically be the same thing as having a priority queue in there. So we can try some different things after that. So the priority queue should naturally order things as you're placing it into the priority queue. So it should be, it's different than an actual queue in that the priority queue naturally puts things into the right order, or it should put things into the right order. At least that's how I remember it working in C++, but maybe I have this wrong. So let me take a look at it again. We have priority queue A, B, 15. Oh, actually, these are also the incorrect order. Change the priority of an existing key. 0, 5, 15. Oh yeah, no, I'm not sure how this is working actually at all. That is unfortunate. Great. Okay, I'm gonna have to take a look at this, figure this out. So I might spend a little bit too much time today talking about these weird implementation details that I should have figured out last night, but I didn't because I thought it'd be straightforward. That happens. Okay, so let me see if I can figure out why this isn't ordered. So priority key behaves similar to a dictionary in that keys can be inserted in priorities accessed or changed using index notation. Let me check something out. I'm going to do priority queue. And I'm going to do C++ real quick. Why don't we order the data and then assign the values? I mean, the syntax cannot PQ equals. Let me see. Insert the keys here. Let me think. Data structures. Oh, I see. So they put PQ at the end there. I think I did what they wanted me to do, but the order is wrong. Even the order here is incorrect. Like, it should be in order, but that's definitely not in order. 15, 5, 10, that's incorrect. So I don't know what they're thinking the priority queue is. Provides a basic priority queue implementation, allowing for arbitrary key and priority types. Multiple identical keys are not permitted, but priority of existing keys can be changed efficiently. That's fine, but like, one second. There is an STD priority queue here. Let me see if they have an implementation detail there. Okay, so here's how it is in C++, and again, this is kind of what I'm used to seeing here. It might be a tree insert. Yeah, I'm not sure. I need to look it up. So again, I apologize for that. Like order the data, we got A equals 14 with quicksort or something like, and then assign 10 and so on. Yeah, so we might end up doing that instead of having the priority queue, just having a vector that flips around. It's just, again, the priority queue is, in my opinion, a better way to do it. So I need to kind of think about that right now. So let me look at the C++ priority queue implementation, because this is what we have for the other Huffman, the Huffman.cpp, that we already have, that's kind of making the visualization that I just showed you a while ago. So we have that visualization working. I mean, Huffman Encoding is also working. We know Huffman Encoding is working there. It took me a while, but we got that one done. I don't remember how long that took. It took like maybe a week or two, if I'm being honest. Okay, so this template void print q is not necessary here. So priority queue of ints q for int n, through all of those variables we push, and we print q. Yeah, see, the first time they printed q here, it was already in order after putting it into the priority queue. So all we're doing here is we're pushing the values here, and then it says 9, 8, 7, 6, and there you go. You know, it is in the appropriate order that you want it to be in. And then they have this std greater, which allows them to push it another way. But again, that's fine because it's printed out in the right order. Now, what's this last one? Using lambda. Oh, they're using some sort of lambda. Also fine. Okay, so let's take a look at this priority queue because it's obviously not in order. So let me try doing a couple of different things. What I want to do is maybe try maybe the natural priority queue you get in datastructures.jl doesn't have an explicit ordering. Maybe what I need to do is read in, let's see, enqueue. No, it looks like it should, but let me try something else real quick. So let me try this enqueue command here. So let's try enqueue. And what I want to do is enqueue pq. In Julia is a functional programming language. So if you're going to change the shape of something, or like change the like the structure of what you're adding in, so like you're inserting elements, removing elements, something like this, you always do it this way where you have like enqueue exclamation mark. And then so I'm going to add in a, let's just say, where am I at? EF is what I'm at. And I want to put this at 0. Okay, 0 was the start. Now I want to do G. Now we'll put this at 10. Actually, let's do 10. Y. H. What order is this nonsense? 12? Yeah, okay, I have no idea how this is doing anything. Yep. This doesn't make any sense to me. Like, okay, again. Hey, TT Designator, thanks for coming in. Also, anyone I didn't say hi to, I think I missed BDC and a few other people. Thanks so much for coming in. Really appreciate it. I hope you guys are having a fantastic day. You know, good lives, all that kind of stuff, whatever it is. Okay. So, it says we're using forward ordering? Yeah, forward ordering is what it says. No, the priority queue is exactly what we want. Hey, the Bandit Dave. It is exactly what we want. So here's the C++ code, right? The idea is we push in an arbitrary number of characters, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the moment we push it into the priority queue, it automatically puts that to where it needs to be in the order. So in our case, if we have the list of different Huffman nodes that we want to combine into a Huffman tree, basically, the idea would be we have this list here, and by putting them into the priority queue, again with some sort of lambda function, but by putting them into the priority queue, we have them all already sorted, right? And so then after they're all already sorted, we combine the two lowest elements, and we take that new node, put it back into the priority queue, you know? and then it's resorted. Then we take the new node, put it back into the priority queue, and then it's resorted. And so by continually resorting this, yeah, each push it resorts. That's the idea. But the thing that's nice about the priority queue, instead of using like an ordered list, is that with the priority queue, we have a specific data structure that is meant to, push and pop elements. So that's what we need to do. We just pop the last two elements, right? And these will always be the two elements in the lowest, these will always be the two, I guess you could say, smallest elements, which is what we want. So if we pop twice, we get the two lowest elements. And then we just combine those two and put it back in. So it makes the Huffman encoding process super easy. You just pop, put it back in, and that's super easy. Whereas with a vector, then what you'd have to do is you'd have to std remove the two values, and then you'd have to put it back in. It gets kind of annoying. But the display is not showing priority, is it? No, the Julia version is not, and that's the thing I can't figure out. Again, with the list, it's just slightly more complicated, and I think that the list is, obviously depending on language implementations, but the list is also slightly slower for certain languages, whereas this is, again, a data structure specifically meant to put data structures in and take data structures out. So, yeah, but sure, a queue is just a limited list. It's just that you have O1 accessing rights, whereas a list, you don't necessarily get that. But again, the queue is exactly the data structure we want here. We don't need to overly complicate it by having a list. It's just for some reason the Julia priority queue is not actually ordering anything. So that's the thing I can't quite figure out. So let me just try this again. So what I'm going to do is priority queue. So what I want to do is have a priority queue again. So let me try this again by maybe changing things up. Is there a note for using a priority queue? A note for what? So here's the Julia, the priority queue here. They have this basic implementation, but again, the thing that bugs me about this maybe it's just not printing them out in order. Maybe you're right, SpeedyFee, is maybe there isn't an ordered print here. Maybe the order is being stored correctly. So let me see what happens if I just DQ PQ. So I'm just going to do DQ, exclamation mark, PQ. Wait. I missed the UE. F. What is F? F is 0. Let's try it again. D. Oh, that is, I think, actually in order. Okay, fine. So the print was wrong, but the order is correct. Fine. Fair enough. I don't mind that so much. That's fine. Okay, good. So if I DQ again, what do we expect? So 5, the next one, what we're looking for is, it looks like C. Yep. And then we should get either a G or an A. Yep, correct. The next one should be a B or an H. B, H, good. And the last one should be an E. Good, and there should be nothing. Good, okay. Fine, kind of freaked out for a minute there, but it looks like the print isn't necessarily the correct order, but when we DQ and NQ, it is fine. I think that's okay. Yeah. Okay, good. So that's fine. A little bit weird, but that's fine. So now we have to make it a little bit more complicated by creating a priority queue of particular structs where the structs are based, where the ordering of the structs is based off of a another value, right? So the idea here is that we have the ordering based off of like some double value within the struct itself. So let's go ahead and construct that. So we're going to say struct. Now, if you're not familiar with Julia, again, Julia is a functional programming language. It used to be that instead of using a struct, they just used type. Now, the struct is basically a class in Julia, but again, because it's a functional programming language, you don't put functions inside of these guys. They're specifically to hold data. They are a type, basically, so like a float or an int or something like that. So rather than putting the functions inside of your classes here, like you would in an object-oriented programming language, maybe like C++ or something like this, you do the other way around, and you just do all the functions act on types. This is clearly backwards for some people, but it's something that I wanted to mention. I usually go for more functional programming language or more functional programming when I can, just because it makes more sense to me. But if it doesn't make sense to you, that's fine, because when we put it in the algorithm archive, you can feel free to implement it in your own object-oriented style. Just that's kind of usually what will happen. Usually Julia is the first language we put in, and then after that, we go from there. Would have gone for Python as the main language. I completely disagree with that. Python's a pain in the butt to read when compared to Julia. Like, I mean, okay, I don't completely disagree. It's just, I find Python much harder to read. Also, there's the whole Python 2.7 versus Python 3 debate. Like, it's just messy, you know? Like, what should you use? I know everyone will say use Python 2.7, but personally, I find Python 3 syntax better and easier to use, and it's what I'm more familiar with. Julia is pretty straightforward to read. It makes sense. Also, it's easier to read for beginners, in my opinion. Like, for example, in Julia, a function, you know, G down here, a function in Julia is function. So we'll say function f of x or something like that, right? Perhaps stream title needs to reflect the language topic too. And then we do end here. That is so much more obvious than having a, let's say we do, I don't know, like print line X or something like this. I don't know, so hey. There's no semicolon necessary. This compared to this. How about we just print X, because we are reading it in X. I mean, this is no question. Like, what does def mean? I have no idea. What does, here, f is clearly a function, you know, this type of thing. Oh, no, this isn't Julia. Okay, let me also briefly mention this. Like, it's not like Haskell or anything like that. This Julia is like, I would say it's a good middle ground. It's fast. It's clear to read. It's not complicated, I don't think. I mean, it's not object oriented, sure, but it's also not. It's also not really that functional. It's not as hard to read as like Haskell or something like that. Perhaps the stream title needs to reflect the language topic. I don't think so. I mean, it's Huffman Encoding. We're using a simple language that everyone should be able to understand. It's really relatively straightforward. Everyone says use Python 3. I mean, some people did, but Julia is the next language on my to-do list. I've only heard good things about it. Yeah, it depends on who you ask. If you ask people who are very into Julia, then yeah, of course they're going to say good things. Okay, so now what I need to do is figure out how to use this priority queue. Now I realize, guys, we're kind of significantly off of Huffman Encoding here. This is my fault for not looking into this last night. I should have looked into it last night. I didn't. That was my bad. Okay, so let's go ahead and create the struct. What should we call the struct? We'll call it object. No, struct thing. I don't know. That's what we'll call it. Inside of here, we'll have a single value, which we'll say is x, and it's going to be of float 64 type. And then we're going to end the struct. Okay, so now we have the struct thing. If we want to create something, we'll just say x equals thing 1.0, and then we should have x.x. It's going to be equal to 1.0. X is a thing with a value 1.0. Good. Maybe I shouldn't. I'm already confusing my notation here, but that's okay. It's fine. My naming conventions are clear, crisp, and obvious, so I think this should be fine. Okay, so now I have to figure out how to sort the priority queue based on this object value here. I think that should be okay, because I think what I can do over here, let's see, what do we have here? Any base order. So let me try something. So what I'm going to do is say PQ, and this is going to be equal to priority queue of, let's say, type thing, which is a type name. I realize, again, notationally that's kind of crap, but we're getting there. Then I guess we want any here. No, I don't want any. Let's think. What do I want here? I want particularly to have this priority queue based on a value, like, you know what I mean? Like we have x, and inside of x, try Swift. some program, some function, something int, string. What? The arrow to string is the thing that gets me there. So let me go over here. Let me see if someone has this already up. So priority queue, Julia, there might be something on like Stack Overflow or something like that. And I want to say sort by lambda function or something. Something in this. Oh yeah, this is gonna be a pain. Okay, so let's see, what do we have here? Here's priority queue. Nope. Here's priority queue. And then we'll see how this goes. I want to know what this priorities of type V means. You know what I mean? So I just need a couple of quick examples here to figure out what we can put in for V. See you, Night Owl. Thanks so much for coming in. Really appreciate it. Have a great evening, I guess, your time. I'm not sure if you're in the US or Europe, or maybe even in Japan, whatever you are. Thanks so much for coming in. See you around. Okay. With priority V, NQ. And then we have forward and backwards ordering. Okay, so I will go through here and I'll figure this one out. Okay, V is a type of values. It could be the type of values, so let me think. So if we do, but that's not what I want. I want to be able to just push something in and pop it back out. NQ, DQ. So what if we do float 64? Okay, that's not how you spell float. Float 64, okay? So now we have priority queue with things and the values of type float 64. And then all we have to do is the following. So now we say PQ what is it? Oh, no, it's push exclamation mark PQ. And then what we say is, no, it's NQ for Pete's sake. NQ, PQ. And then we're going to say some value, which I'm going to say is going to be equal to X. And then we're going to say X dot X. Okay, fine. Now what I want to do next is create another value, which I'm going to say is going to be equal to, oh, let me try something else. Let me try X is equal to thing of 2.0. And now I'm going to do the same thing, NQ here. Okay, so now let's try the same thing there. Okay, that obviously didn't work. Thing 3.0. And we NQ here. Now what I want to do is DQ. UE, exclamation mark of PQ. And what I'm expecting to do is get thing 1, thing 2, thing 3. Good. So now let me try something else. Can you program an AI? Wait. Would you... Wait. Case type of value. Yep, you're totally right, TT designator. Wouldn't you need to do priority queue PQ vector int? Yes, basically something like that. You can program an AI. I'm sorry, I just hit the microphone. That wants to be my girlfriend. Unfortunately not. Even if it is an AI, you'd have to have some redeeming part of your personality in order for it to want to be your girlfriend. So that's unfortunately how it is. I know I tried myself to make an AI for me, but it didn't work out. So then NQ vector A. Yeah, so this is basically how it would work. So let me try this one more time. So we're going to have X is going to equal to thing 3.0. X is equal to thing 1.0. Oh, oops. Let me go ahead and NQX. We're going to do thing 2.0, and we're going to NQ X again. Let's try, let's see, thing negative 2.0. We're going to NQ that. And now let's try again with negative 4.0. Okay, and we're going to NQ that. So now we have a priority queue filled with a bunch of values. And these values are double values here. Use the frequencies as keys, use nodes, one for each symbol, as values. Make a new node with 2 popped nodes as children and reinsert that new node. TT designator, that is exactly what we're doing. That was kind of the whole point in figuring out how priority queues worked so that we could do this pretty straightforwardly. Yep, that is exactly how we're doing it. So, good job. So you expect the AI to say, no thanks, I'm out, BB dev. I know, search for something better. Yeah, that's probably about right. So I'm just going to very quickly make sure this is working the way I expect it to. So we're going to run DQ here, exclamation mark, and I'm going to run PQ there. I think -4, -2, 1, 2. Good, in the order I want. So we have a basic way of using priority queues. I'm not going to say this is necessarily the best way. I'm going to have to do a little bit more research, but let's go ahead and get to the point where we can build a basic binary tree with Huffman encoding using the nodes that we have here. So let's go ahead and get that done. No, it's good. So DG. Okay. Yeah, sorry, TT Designator. I had to kind of go off on a sidetrack and get some stuff done first to figure out everything. Okay, so the first thing I'm going to do is just go ahead and write down all the functions we're going to need, and then we're going to fill those functions in as we go along. You're fine, TT Designator. You're great. Don't worry about it. The whole stream has been kind of me figuring things out. As I mentioned, this will probably take 2 days. I'm anticipating today to have some basic stuff done, and then tomorrow just kind of push through everything. I mentioned at the start of today's stream that I should have looked into this priority queue stuff last night, but I failed to because I was too busy writing down the pseudocode and stuff like that. So like I said, we're going to need a couple of different functions here. So I'm just going to go ahead and write them down, and then we'll say what we need in all of the different functions. So we have some kind of skeleton to work with, and then we go through each thing bit by bit. So function. And the first function we're going to need is one that's like create tree. And what are we going to have to read into this one? I think straightforwardly, we're going to have to read in the encoding string that we're going to be iterating through. So I'm just going to call this one, what should we call it? The encoding string. I guess we'll call it, are the nodes and the keys? Aren't the nodes the keys and the frequency values? Wait. Aren't the nodes the keys and the frequency values though? Yeah, the node is defined up here. So we have a right node, a left node, a parent node, and a weight. And what we're going to be doing is sorting based on the weights, which I assumed was what TT Designator said was the frequencies. I apologize if I misunderstood that. Okay, so we have create tree here. What we want to do is read in some sort of string that we're going to be encoding. So I'm just going to call it maybe encoding. I'm just going to say phrase, okay? And this is going to be a string. And here, okay? What is PQ ordered after? It will be ordered after the weights. So the values, not the keys themselves. Because if it's in like alphabetical order, that doesn't really help very much. But if it's in the order of the weights, which is how frequently a string or a character appears in the string, then we have an idea of how to order it from there. Now these weights I've set to be float 64, but honestly maybe it's better just to have them as ints, because if they're integers, then it's easier to count and everything like that. I'll put a note there, or I'll kind of put a mental note here. We can probably ints instead of doubles for weights. Okay. So we have this one, which is going to be creating the tree. Now we have a whole bunch of other functions that we have. Yes, sorry about that, JSPP. I apologize for being slightly confusing. I just apologized twice in the same sentence by using 2 different words. I'm getting better. Okay, so we're going to have create tree. Create tree is going to return back a node. So what we want then is another function. And this function is going to specifically create the dictionary that we're going to use. Now in principle, we don't need the binary tree back. We could actually just output the dictionary from here. So let me go ahead and do that here. So this outputs the dictionary, or the encoding. I want to say map, but I know it's a dictionary. So I'm just going to say dict to be used for encoding. Now the question is, do we actually want the binary tree? Or do we just output the map? And I think having a large function, will we need the tree for anything later? That's the question. For now, we'll just say it's called create tree, but actually we'll just call this create map. Okay, on top of this, we're going to have a basic depth first search. So this will search through the tree to create bit strings for each character. Okay, so we're going to just need a function. And I think DFS should work. And it's going to have to read in a Huffman tree. So we're going to say a tree, which we're going to say is, let's say n, which is a node. And there. So I haven't yet put the depth first search in there, but we know we're going to need this. Here we're going to say create tree. And this one outputs, just dd paste there. This one will output Huffman tree. To generate a dictionary for encoding. And then down here, we're going to have another function, which will be create dictionary. And this will read in again, n node. In fact, maybe we just say it's, we'll just say node, something like this. And okay, so what other functions do we need? We sort the priority key based on the frequency of the symbols. We always want to pop the two nodes with the smallest frequency. Exactly. Why use doubles? Wouldn't doubles be just the outcome of ints calculated into percentage? Exactly. So that's why I say we could use ints instead. I might change that in just a second. Okay, so after this create dictionary function, we need another function which will be encode. Encode, which means we need to read in both the dictionary that we're going to be using. So I guess what I will say is we need to read in the map, which we'll call a dictionary between two different values. Those values will be a string and I guess another string. So one will be the bit string, the other will be the string here. Okay, so now we also want the actual string that we're reading in. So this will be the phrase, which will be string. Okay, we're also going to want something similar for decoding. So I guess this is going to be function decode. In here, we're going to read in the map, which is going to be, again, a dictionary between two strings. And also the bit string. How about bit phrase, I guess? Bit string. Which is going to be a string. Okay. Finally, we need the main function here, which will be for 2pass Huffman. So a function, and I guess I'm going to call it 2pass. Which we kind of know what we're going to be reading in here. So let's go ahead and do phrase, which is going to be string. And then in the end, we'll be calling 2pass Huffman with some sort of phrase, which we'll just say, hello world for now. Okay. So this is going to be the code that we're going to be writing, all the different functions, everything that we need. We're going to have some sort of depth first search to go through the nodes of our tree. And this will allow us to figure out, kind of the bit strings and stuff like that as we go along. We need something to create the binary tree first. We need something to create the dictionary. Again, creating the dictionary will have us doing some sort of depth first search on the tree. We have an encoding function, a decoding function, and the final overall function, which will be our main function, which is 2pass Huffman, which is the overall name of this particular encoding scheme that we're using. So that's the skeleton of what we're doing. If there's any questions, feel free to let me know now. I'm going to get a quick sip of water before we start writing the first bit of this, which will be the create tree function. And then we can kind of go from there. This will be a little bit long. In fact, this will probably be the most complicated algorithm we've put on the archive so far, but it's also one of my favorite algorithms, so I'm pretty excited to see where this goes. Okay. Now, at the very start of this guide, there's one thing I forgot to do. Ooh, what was that? Forget that. And that is using data structures. And I'm going to put a quick comment up here saying this is for the priority. Come on, dog. One of these days, I will be able to spell things, but that is not today. Okay, open up the next line. Speedy Fee, thank you so much for coming in. We'll be back tomorrow at the same time, same place, doing basically the same thing. So feel free to come in. Really appreciate seeing you there if you come. Understood it by now, FFT is more complicated. You might be right, the FFT was pretty complicated. But let me see, I think the FFT wasn't as bad as it could have been. Oh, it was quite bad for some languages. Yeah, okay, so for C++ and C and C#, I would say FFT was probably more complicated. You're probably right. But the nice thing about this one, unlike the FFT and unlike the other stuff that we did before, what am I looking for? I'm looking for read. Let's see, so here's the FFT. The nice thing about this algorithm is it actually ties in the tree traversal stuff that we did before, which is kind of nice. DFT. Yeah. Cooley Tukey. Yeah, okay. So honestly, in Julia, this isn't so bad. But in C, it's ugly. Yeah, I remember this getting quite ugly in C. Oh, okay, fine. You're right. So I think that the FFT is more theoretically challenging to figure out or to understand how it's working, because you really just have to think about things in like its matrix notation and that type of thing. And especially because they play this dumb trick with the butterfly diagrams with this omega-2 equal negative omega-1 nonsense. But overall, I think it's okay. I need to redo some of these diagrams. Man, I wish I was working on this project like full time, because if I was, I would totally be able to just go down and just like revamp everything, you know, just fix it all up, make it cleaner, easier to read. But we'll get there. We will get there eventually. It'll just take longer. Okay, so the first function I'm going to create is actually the create tree function. A matrix. Yeah, you're right. Fine, fair enough. If you don't know what a matrix is, it's very difficult to think about. But imagine a matrix as a two-dimensional set of values or something like that. So for example, in Julia, this is a matrix. I don't know. There you go, matrix. It's just like a 3x3 array. It's not anything particularly complicated. Usually people try to make it more complicated than it is by using weird notation. I personally am someone that does this a lot accidentally. Like I'll accidentally just use a phrase that some people might not know. So if I say something that you don't get, anyone doesn't get, feel free to let me know, and I'll totally address it as soon as I can see it in chat and stuff like that. Yes, okay, good. So let's go ahead and create this create tree function. We already know how priority queues and everything works. So in principle, we can just go ahead and create the tree and return it. So I'm going to go ahead and do that in this 2-pass Huffman guy. So what I want to do then is just say create tree, and this is going to be creating tree with the phrase that we're reading in. Okay, so now let's go in here and let's go ahead and try it out. So the first thing we need to do is iterate through all the different values in the string. So just to make sure I'm doing this correctly, I want to say phrase is going to be equal to hello world over here. And then what I want to do is say for I in phrase, print line I, and good, works exactly as anticipated. So we're going to say for I in phrase, end. And now what do we want to put in here? Basically what we want to do is go ahead and create the vector of double values that we're going to be working with from here. So what I want to say then is, actually, in fact, this should probably be a dictionary. Or we could go ahead and do, is it easy to sort a dictionary? Let me think, sorting dictionaries in Julia. Let me Google this. Sorting, is it possible to sort a dictionary in Julia? Sort, collect. Let me see what happens. So what I'm going to do is go ahead and create a very quick dictionary, which is going to be, I'm just going to say it's going to be between an integer and a string. So we're going to say x is going to be equal to, we're just going to say it's a dictionary, which I think will automatically, yep, any. So now we're going to say is x of h equals 1, E equals 2, then we'll say Y equals, let's say 0, okay? Yeah, so that's the thing. I'm trying to figure out, if I run X, I'm trying to figure out what happens. So what I want to do is create, basically a list of all the different values. Couldn't we just add the priority queue and then look if 1 key exists and 2? Oh yeah, we could create the priority queue exactly here. One second, what happens if we do, let me try something real quick. So what if we do a priority queue here? So we're gonna say PQ is going to equal to priority queue. And let's just do this. And now what I wanna do is PQ of X, S, why not, is equal to, oh my gosh, one of these days. Okay, now I wanna do PQ S plus equals 1. Can I do this? That works, great. So then what we can do is I need to check a few other things. One second about this priority queue in Julia. I realized that today was supposed to be mostly Huffman Encoding, but we spent most of the time just looking at what a priority queue was. Apologize for that, but that's okay. So what I want to do is peek, return the lowest priority key without removing it. BTTV is broken, not like this. I can't uptime? Oh, I'm so sorry. I've actually never used, I think it's better Twitch TV. Hey, Fled, thanks so much for coming in, man. Really appreciate it. Okay, so what are we gonna do next? What I need to do is figure out, uptime has been 1 hour and 41 minutes. I start streaming at 5 o'clock in the morning every morning, so, well, every morning I stream. It's always at 5 o'clock. So, it's 6:41, 6:42 now my time, and that's how it is. I think the time has come where Simbot has to take that task. Yep, I don't know why I'm typing this in chat, but that sounds good. Okay, so what am I going to do next? What I need to do is check to see like the size of priority queues. So let me just do very quick, length of PQ. Good, that seems to work just fine. Now, let's see, how do we check if an element exists? Let's see. PQ of, let's try S here. Okay, so now what I want to do, it just seems easier to do with a dictionary. I know, but I just have the urge to type uptime the second I enter a stream. It's pure habit. That's fine. I can tell you the exact time just because, you know. Okay, so I think maybe a dictionary is best for now. And then it says that we can sort the dictionary. So we do have a dictionary, which is X. And let me just very quickly try sorting that dictionary based on what we had before. So it says sort also by keyword, which means you can do the following. And so it's going to be sort collect dictionary 1. So let's try this. I'm going to do sort. And let's do, what happens if I do sort X? Yeah, of course that doesn't work. So let's try sort collect dictionary 1, which is going to be X, and we're going to try by, actually, what happens if we just do this? E, H, A. Okay, that actually seemed to work. Okay, fine. So then we have the highest value on top. Okay. So I guess this does work. So I'm going to say, temp dictionary. Actually, what should I call this? I guess I'm just going to call it, I don't know. I need the bot to tell me exactly how long the stream has been up with the seconds and everything. This is supposed to be done by bots, not humans. That's wonderful. Do you maybe have a list of all commands the old bot fulfilled? I mean, Nightbot should still be up. So for example, if I run, if I run Discord, it still works, right? So it should, if I can spell Discord, there we go. Also, if you have not been on my Discord channel, feel free to go there. It's kind of a Discord channel for all Twitch programming, but it's kind of just used by my community nowadays, which is a little unfortunate, but we also have Happy Little Rat there, and that's kind of nice. So TT Designator, that one hasn't been working since last year when I was allowed to show those types of images, but you know, one of these days. I can remove my shirt if you want. I have a shirt under it, so it's fine. Okay, so let's just go ahead and just call this, I don't want to call it temp dictionary because I think that's kind of a bad name. What I want to call it is, I'm just going to call it weights. And this is going to be equal to, this is going to be equal to a dictionary between two values, which is going to be a string and also a integer, which is going to be int64. So in here, what I'm going to say is weights of I is going to be plus equals 1. And so what I want to check over here is x of h. Oh, that's not correct. X of, let me try x of y, because I know that doesn't exist, equals 0. So in principle, this should work. So what I want to do very quickly is print x. So let's do print line x. Okay, it's close enough. So print weights, and let's see how this works out. So I'm going to go over here and I'm just going to include, and what I want to include is whatever I called this, which would be Huffman.jl. Hopefully this builds. Cannot convert an object of type character, an object of type dict string. Okay, so this is a load error on 21. Weights of I. Weights is equal to a dictionary. Did I do this incorrectly? Let me think. So we say x is going to be equal to some dictionary here. Oh, let's do it the following way. Let's just do $, and here. Let's try again. Including redefinition of constant node. Line 5. Struct node. Oh, does node already exist? Oh no, I know the problem. Let's control D. Let's run Julia. Huffman.jl. Load error. Key H not found. Yep, that's about what I expected. So because because H doesn't exist already, my question is, can I do the following? So I'm going to try something real quick. So x is going to be equal to dictionary here. And I'm going to say x of, let's say, h again, is going to be equal to 0. And I'm just going to say, what if weights of I doesn't exist? Yeah, I need to figure this one out real quick. So now I want to say, if, how to tell if a dictionary element exists. Let's see. Dict A, let's do exists. Dict A has key. So let's do has key. This seems like a thing. And we're just going to say X, and we're going to say H. True. False. Great. So we're going to say if, sorry about that. If weights, let's see, has key, weights of I, that's what I want. And I'm just going to go ahead and DDP up here. And we're going to put an else here. Weights of I equals 1. And let's go ahead and Control D here and run last Julia Huffman. H not found. What? Let's see, create tree on line 21. Has key weights of I. Oh, I'm sorry, I did this incorrectly. It should be weights. Julia Huffman. Okay, so it looks like we have a an appropriate list here. So now we just want to sort this appropriately. So let's go ahead and do that, as we had it before. And if you can do the same thing with PQ, you can basically get rid of the dictionary. Yes, that's the thing I'm trying to think about right now. James, your monitor is 27 inches, right? Yes, my monitor is 27 inches. If your monitor is not 27 inches, I'm hoping you can still read most of the text, particularly in these two terminals, but maybe not in this terminal over here. This terminal over here is a little bit smaller, but it's meant specifically for chat, so I think it's probably okay. Let me think. So I think, let's see, if we could do it with priority queue. I'll have to think about that one. Can we do it with exclusively a priority queue? We could have a priority queue. Yeah, the thing is we have to update values iteratively. And so I don't know if we can necessarily do that. So let me say sorted. Let's just say sorted weights. It's going to be equal to sort of collect. And we're going to say weights. And see what happens. And then what I want to do is print line. Weights. No semicolon. Make that. Why am I making it? Julia. Any space 1 D1. Hello world, this is correct. W1, that's correct. This is not sorted. Julia Huffman.jl. And if no, create new node. Do we have for, let me try something with the priority queue, because if we do, maybe it's okay. So let's try Julia Huffman.jl. Ooh, that's what I want. Let's run Julia. And let's try using data structures. And let's try something real quick. So I'm going to say, I'm going to buy 24 inches one in a few days. The monitor I currently have is 15.6 inches. Videos must look amazing on 27 or 24 inches. Probably. It's okay. The 27-inch monitor is quite nice. So I'm going to say PQ is going to be equal to priority queue over here, just to give something a shot. And then we're going to say PQ of, let's say, X is going to be equal to 1. Now I want to just say has key. And this should, in principle, work. PQ X. Yeah, good, that works. So let's do the same thing over here then. Now the question is, can I just go ahead and create the node here? You can read everything from your iPhone. Okay, good, fair enough. Good. So if you can read pretty much everything, then you're fine. I used to have, when I started streaming, I had 4 terminals up, all of which were this size over here, and it was just impossible to read everything. And so people got kind of mad at me, so I increased the size of the terminal, and then I couldn't read it, so then we had to kind of go back and forth. But I think now it's okay. So what we're going to say is weights. Actually, in fact, you might be right. We might be able to go ahead and start creating the priority queue as it is now. So the key will be the node. No, we're going to have to create 2 priority queues. I think that's going to be the best way to do it. So we're just going to say weights, and this is going to be equal to priority QUEUE. There. And the reason we want 2 queues instead of just 1 is because otherwise we have to continually create a node and check whether that node is available instead of checking whether this character is available. And I think that's probably a little bit easier to do this way. So now we have the weights available there, and what we're going to say is while length of weights is greater than 1, and here. And now we're going to create the nodes. Also, for the record, we don't have so much longer in today's stream. I got to go in about 5 to 10 minutes. So my hope is just to get this tree basically created and then go from there. If we have further discussion, or if you want further discussion, feel free to go on Discord, where we can talk more about it at that point. So we have weights priority queue here, length here. Good. So now we have to create the node. So in here we're going to say to iterate through. And here I'm going to say, oh, that was not what I meant to do. And here we're just going to say creating weights. Okay. So we might just get the nodes created, and then we'll talk about how to add them together in just a bit. Adding them together should be pretty easy, so we should be able to do it. Okay, so while the length of the weights is greater than 1, we're basically going to create a whole bunch of different nodes here. So we're going to say weights, let's say nodes is going to be equal to priority queue. And this is going to be of 2 different types here. So we're going to have node n, which is going to be, oh no, what am I doing here? Node and int 64, I think is correct. Here. And then we're going to pop up here, and I'm going to change this weight to an int 64 because I don't think we really need a float. Okay, great. So now we're going to pop down here. We have the priority queue generated. Let's just go ahead and keep enqueuing the different nodes as needed. So let's go ahead and create the node that we need. So we're going to say temp node is going to be equal to node, and we're just going to read in the appropriate values here. Now, the thing is, I think I'm going to have to think about this one real quick. We have right, left, parent, weight, and key. So let's say current weight. So we're going to say weight is going to be equal to, let me just real quickly, DQ, PQ, X. Oh, I see. So what we need to do then, let's see what happens if we PQ here, and let's do peak real quick of PQ. Let's say 1, 2, great. Okay, so we're gonna say weight is gonna be equal to peak of the priority queue that we already have, so weights. And then what we want to do is number 2, so that should be the weight, and then we're gonna say the string that we're working with here, which is going to be the key, is going to be equal to pop, DQUEUE weights, something like this. Okay, so this should give us a string, it should give us the value, and this should be okay. Why do we have left and right? So in the end, what's going to happen is we have this tree, right? And we have a single node, and it's going to have left and right children. So the left and right will be the children of the node, and then we have a parent on top of that. So each node has 2 kids. Those kids are going to be right and left. Now I'm going to have to create like an empty node to be put into this value, or into this struct here. So let me just try something down here by doing node, just initializing it here. Then we're going to want to do weight and key, which is going to be key here. After we have the temp node, basically we put this into the priority queue we want. So then we're going to do NQUEUE, exclamation mark, and it's going to be nodes. And what we want to enqueue is the temp node. Something like this. Yep, children. So just to make sure this works the way I expect it to, enqueue, and we're just going to enqueue PQ with, can I do this? Has no field first. Let me see how enqueue works. Let's see priority queue. Yep, priority queue here, enqueue. I also need the value, so it's going to be temp node. Oh, it's going to be temp node, and then followed by the weight. Good, that should be correct. Yeah, so I could do left and right, but yeah, you're right. I don't know if it's actually that much more descriptive, because it is a binary tree, and you kind of know it is left and right nodes though. So I'll take a look into that in a second. So this should in principle create all the nodes. So the last thing we need to do is then combine them all into a binary tree in the end. So finally we're going to say node. And I guess I'm just going to call this, I guess we're going to call it Huffman tree. And we're going to call this a node here. This is a very basic node. Nothing complicated about this. And what we're going to say is while length of weights. Actually, we're going to say length of nodes is greater than 1. We're going to pop down and just basically keep enqueuing and dequeuing, adding them together, and then go from there. Yeah. Okay, so let's go through. Now all we have to do is write this last bit here. And let me think, what do we need to do? I don't think this is going to be too complicated, so let's go ahead and give this a shot. So we're going to say node 1 is going to be equal to, and this is just going to be dqueue. Wait a minute. Yeah, this should be correct. Node 1 is equal to dq of nodes. Right? And then we're going to say node 2 is going to be equal to dq of nodes. So we're taking 2 nodes in, and then we're going to enqueue a final node here. So we're going to say temp node is going to be equal to node. Now, for the parent, for the right guy, we're going to put in node 1. For the left guy, we're going to put in node 2. For the parent, we don't know yet, so we're going to say node, empty node, and then we're going to say the weight, which is going to be node 1, weight, plus node 2 dot weight. Oh, that's not what I want. Plus, and then for the last one, we're going to put in an empty string for the key, because there's not a key for these guys. And then we have to enqueue the temp node. So it's going to be enqueue, pq, no wait, what are we doing? Enqueue, exclamation mark. I need an exclamation mark here. Oh. There, and then we're going to enqueue onto nodes. What we want is pq, so we want temp node, and temp node dot weight. Put a dot there. Okay, so that should be okay for the enqueuing. Now there's the other thing I need to do, which is update the parents. So now we'll say, how do we know who the parent is? Oh, I know how we know who the parent is. So now we're going to say node 1. So how do we do this? Node 1.parent is going to be equal to temp node. And then node 2.parent is going to be equal to temp node. And this in principle should work. So we take the 2 nodes, we add them together, we point them to the parent, and then we put the parent back into the queue, and then we keep adding onto that until eventually we have a single node that we're working with. Now, what is that single node going to be? We will call that one Huffman tree, and it looks like what we want that to be is the final node here. So we're going to say R2, and then finally we're going to say Huffman tree. It's going to be equal to dqueue here, and it's going to be of nodes. And that should be okay. So this is my first kind of skeleton of how to create the tree and everything to work with. I think for now, I'm going to go ahead and end the stream here, and then we're going to test it and work with it tomorrow. And then I think after that, I think we can get everything else pretty much done by the end of the day tomorrow, and then we can work with the canonical Huffman encoding after that. So we've got a lot of stuff to do, pretty excited for it, and I'm hoping it does okay. The empty nodes might be redundant, that's something I need to work with. And I'm not sure if this will even compile, so I'm not going to test it right now, but this is basically the skeleton of what we have to work with. So I'll kind of test it tonight, get things done, get things rolling, and see how everything works from there. Anyway, guys, I want to thank you guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we continue working on Huffman encoding, hopefully getting this version completely done and getting it ready to put on the algorithm archive, and maybe hopping into even the canonical Huffman encoding, which should be a lot of fun too. I'm pretty excited for it. I realize that these types of streams, I want to do more of these types of streams in the future is something I wanted to point out. Like, this is the kind of stuff that I really enjoy doing. And even though we don't get as many like cool visualizations and stuff like that, I do think that this is kind of more fun in general, for me in particular, and hopefully is more enjoyable for you guys too, even though we have less visualizations, and you might have to think about it a bit more. Again, if you ever have any questions, comments, concerns, feel free to let me know in the future, and also feel free to hang out on Discord, which was just linked by JSPP. And I think that's all it. So let me know what you guys think, and I will talk to you later. Bye, guys.